Hello everybody, welcome to my channel, and my name is Dave. First of all, I want to thank everybody who wrote in with questions or requests for my channel. Second, I also want to apologize as I've been a little bit busier than usual. I promise that when I am a little bit less busy, I'll try to make more videos and I will try to answer more questions or requests for all of the viewers out there. With that said, today's question comes from Namita, who is in Boston. Like many of the viewers of this channel, she has been taking a summer class, and this was one of the questions in one of her problem sets. So today we'll be looking at integrals and derivatives of nested radicals. So I think the trick to solving both of these is to find a more convenient closed form of each expression. What we mean by a closed form is some kind of expression that terminates. It has a set number of operations or expressions. With that said, we will let y equal the square root of x plus the square root of x plus the square root of x onto infinity. Why do we want to do this? Well, we can realize that since this is an infinitely nested radical, there is in fact another infinitely nested radical inside the first one. So writing it in this form lets us write y equals the square root of the quantity x plus y. When we square both sides, we will get y squared is equal to x plus y. And then moving the y to the right-hand side, we will get y squared minus y is equal to x. And finally, moving the x, we will get y squared minus y minus x is equal to 0. At this point, we can use the quadratic formula to find an expression for y. If we let a equal 1, b equal negative 1, and c equal negative x, and plug these into the quadratic formula, we will get y is equal to 1 plus or minus the square root of negative 1 squared minus 4 times negative x all over 2. And when simplified, this gives us 1 plus or minus the square root of the quantity 1 plus 4x over 2. At this point, we need to take a look at our expression. Should we use 1 plus the square root of 1 plus 4x? Should we use 1 minus the square root of 1 plus 4x? Or should we perhaps use both? The answer to this is because our function has a range of y is greater than 0, we need to make the thing that's equivalent to it also greater than 0. So we will simply restrict the definition of y to y equals 1 plus the square root of 1 plus 4x over 2. At this point, this thing will become much easier to take the derivative or take the integral of. So we can take the derivative by using a combination of the power rule and the sum rules. So we have 1/2 times the derivative of what's inside the parentheses, which is 0, plus 1/2 times 1 plus 4x to the negative 1/2, that uses the power rule, and finally multiplied by the derivative of what's inside the radical. If we do this, we get that the derivative dy dx is equal to 1 over the square root of the quantity 1 plus 4x. However, we have to be careful once more because this expression has a domain of x is greater than negative 1/4. However, the original function has a domain of x is greater or equal to 0. Therefore, for clarity, we will write down that the derivative dy dx is equal to 1 over the square root of 1 plus 4x, 4x is greater than 0. Moving on, let's take a look at the integral. So, of course, we can split this up into two integrals based on the sum rule for integrals, and we can move the 1/2 to the outside for both integrals. If we let u equal 1 plus 4x, this means that du is equal to 4 times dx, and it means that dx is equal to 1/4 du. We can now carry out the u substitution on this integral, and we get 1/2 times the integral of the square root of u times 1/4 du. And this gives us 1/8 times the integral of the square root of u with respect to u. And we can multiply this out, and we would finally get u to the 3/2 power over 12 as the integral for that red integral at the top of the screen. However, we have to now substitute back for u, and this gives us 1 plus 4x to the 3/2 power over 12. Now, we combine the two integrals, and the integral becomes 1/2 x plus 1/12 times 1 plus 4x to the 3/2 power plus the constant of integration c. Once again, we restrict the domain to x is greater or equal to 0 to match with the original function. Now, let's move on to the second question. In this question, we are asked to find the derivative and the integral of this expression, the square root of x times the square root of x times the square root of x times the square root of x, which is infinitely nested. If we take a look at some of the subcases, we would find that the square root of x is equal to x to the 1/2 power. If we nest a square root of x within another radical, we get x to the 3/4 power. Repeating this one more time, we get x to the 7/8 power. So it seems that for each iteration, we are going to approach x to the p. But what is the value of p? We can also see for each successive iteration, it differs from the previous by a power of 2. So this would be a geometric sum with a common ratio of 1/2. For example, 3/4 is 1/4 more than 1/2, and 7/8 is 1/8 more than 3/4. It happens to be a relatively simple matter to find the infinite sum of a geometric series. In this case, a is equal to 1/2, and r is also equal to 1/2, meaning that p is equal to 1. Therefore, in the end, this infinitely nested radical reduces to the very humble y equals x. This can easily be used to find both the derivative and the integral. So as we all know, the derivative of x is simply 1, and the integral of x is x squared over 2 plus c. And for both of these, the restriction that x must be greater than 0 also applies. So if you've watched this far, I want to say thank you very much. And as a way to say thank you, I want to provide you with some bonus material. When we were finding the derivative of the first expression, y equals the square root of x plus the square root of x plus the square root of x, infinitely nested, we found the expression y squared equals x plus y. Now this is simple enough to resolve using implicit derivation. So if we do this and we take the derivative of both sides, we will get 2y times the derivative of y is equal to 1 plus the derivative of y. Notice here I've used y prime as my notation in order to save space. We can rearrange this and we would get 2y times y prime minus y prime is equal to 1, and this means that the quantity 2y minus 1 times y prime is equal to 1, or that y prime is equal to 1 over 2y minus 1. We can now take this expression y prime is equal to 1 over 2y minus 1, and we can substitute the found value y equals 1 plus the square root of 1 plus 4x over 2. If we do this, we will find that we get the exact same derivative as we did earlier in this video, namely that the derivative of y is equal to 1 over the square root of the quantity 1 plus 4x. All right, everybody, so this was the video. In this video, we looked at how to find the derivatives of nested radical expressions. If you liked the video, please subscribe and give me a thumbs up. Thank you very much.